Okay, so here we're looking at 7.4, which are the graphs of the sine and cosine function, where we're including what we call the amplitude and the vertical shift. So a and k, you'll see them here, are kind of these added numbers into the sine and cosine function, which we call parameters. And you can kind of think of them as like, we say parameters in conversation, like the parameters around something happening. They're kind of like the required constants or required conditions that's set up that make something particular. So in general, sine and cosine fluctuate between 1 and -1, but we can have particular wave functions that model circular motion that, the Ferris wheel might be bigger than another Ferris wheel, or, a bike tire is larger than a car tire, vice versa, things like this. So the particulars are set up for these parameters, where the structure of the function, it being sinusoidal, a sine t plus k, might be the same. These numbers make them what pertain to the situation. Okay, so finding a and k, or if we have the function, knowing what a and k are in order to graph it or pull some important information from the function, these are key parts of this section. And we'll also look at the domain and range of these functions. So before we do that, I want to note what I call the vanilla sine and cosine. Vanilla kind of meaning like even though vanilla is a flavor, there's no added flavors or parameters to these functions. Y equals cosine of t on its own looks like this, okay? And you would be helping yourself to memorize the shape of this graph, where it starts at a maximum of 1. It achieves its minimum of -1 halfway through at an input of pi. So starting at 0, going to pi, it achieves its minimum down here at -1. And then it achieves its maximum again, coming back up here to a height of 1 after 2 pi. And then it obviously repeats. It does the same thing over and over. So you can just remember this snapshot of it. Knowing that cosine starts at its maximum and ends at its maximum is very helpful. Knowing that it bounces between 1 and -1 is helpful. And knowing that its midline is 0, or y equals 0 to start with, is helpful. Because when we play with this function to fit a situation, those are the things that we're going to play with. How far does it stretch away? How far are those peaks and valleys of this function? And what does it oscillate around? It starts bouncing around y equals 0, the t-axis or the x-axis, but we can move that, because that might not be the equilibrium level of the system that we're playing with. So it starts at, for cosine, we'll just write these in here, it starts at a max of y equals 1. It has a minimum of y equals -1. It has a period of 2 pi, and it has a midline of y equals 0. Okay, this is what they start at. This is what cosine starts at, rather. And for sine, as you might have already read about, sine is really just, and we'll see it more too in 7.5, sine and cosine are really the same function, just set off by pi over 2, right? If you cut the function here and looked this direction, you'd see, oh, this looks just like cosine, and you'd be right. They are really closely related in that way, but it's there's enough applications where we define them separately. So y equals sine is over here. It starts at 0 instead of its maximum. It starts at the midline, heads up to its max here at pi over 2, back to the midline at pi, down to its minimum at 3 pi over 2. Right? And again, you can also think of this as like 90 degrees, 180 degrees, 270 degrees, and then 360 degrees, or 2 pi radians of rotation, and it's back to the midline of y equals 0. So this one starts at 0. Oh, we didn't put this in over here. This starts at its max, or y equals 1. And this starts at the midline, or y equals 0, in its vanilla form. Its max the same is y equals 1. Its min is y equals -1. Its period is 2 pi, and its midline is y equals 0. Okay, so these things are all the same. Sine starts at the midline, cosine starts at its maximum. Now, when we start messing with these things is when they change, obviously. So what I'll do in the next video is show you how we can stretch these things and flip them and shift them around.